Good morning, Year 4, and welcome to Thursday's maths lesson. So we're going to be learning about some quadrilaterals today. So what I'm going to do is I'm going to do a bit of a mixture of using the PowerPoint that I've put on the OneDrive and some shapes that I've got here as well. All right, so that's just so that we can have a little bit of a mix-up of what we're doing. Now, I'm going to share my screen so that you can do the date and woe, and we can do our starter activity today. So let's go. Right, not long left now until we'll be doing maths back in school. And I've just realised that I've actually got the wrong date on here. So let me end this. For some reason, I put the date on for last week. So it's actually the 4th of the 3rd. Can't believe we're in March already. 4th of the 3rd, 21. So we're going to understand quadrilaterals and sort them based on their properties today. Now that's quite a long learning objective, but if you pause the video, you should be able to write that down. If you want to, you can shorten it to understand quadrilaterals. It doesn't matter too much because you would be sorting them on their properties. Now, whilst you do that, hopefully you've done that, I should say. I would like you to be able to name all the quadrilaterals that we need to in Year 4 by the end of the lesson today. You've looked at them before, so this really is a refresher. We did it back in the autumn term, so it was a while ago. And I want you to be able to describe their properties. So at a minimum, I want you to be able to name the shapes, the different quadrilaterals, but also start to be talking about them using their properties. So pause the video, and this is your starter today. How quick can you do it? See how quickly you can answer the questions in your book, and then I would like you to unpause the video and you can mark your answers. So I'm just going to wait for a few seconds just whilst you pause it. Right, fantastic. So let's have a look then. Can you mark those? Pause it if you need more time. So 30, 64, 3,670, 42, 18 and 0. How did you get on? Bet you did great. Big thumbs up from me. So today, vocabulary check then. So we've looked at some of these words this week. Perpendicular, equal, right angle, parallel, interior angle might be something that's a bit new, and diagonal. So let's see, what joins up to what? Can you guess? Pause it if you want to have a guess. Right, so perpendicular. So a line or a plane of an angle of 90 degrees. So if you think of perpendicular lines, I'll show you when I come off anyway. Perpendicular. So they make a 90-degree angle. Okay. But I'll draw that and show you. I'll draw it and show you. So that is like a perpendicular line, okay, where the two lines join at 90 degrees. All right, it might not be that way around. You might have it could be that way around. Could be that way around. Could be that way around. That's those different orientations. All right. So then the next one, equal, meaning the same as. Right angle, so an angle of 90 degrees. Parallel, so lines that are the same distance, they have the same distance between them, but they will never meet. So think of your tram lines. Again, they could be that way, they could be that way. But the important thing is that they are the same distance apart, so they're never ever going to meet. They'll just continue off into the distance. Interior angle, so if we're talking about interior angles, we're talking about the angles on the inside of the shape. And then the last one is diagonal, so a straight line joining two opposite corners of a straight-sided shape. So what is a quadrilateral? Have a look at that shape. What makes it a quadrilateral? It's a 2D shape. There, and there's the big one. It's a four-sided shape. Can you remember now? A quadrilateral is the overarching name for four-sided shapes. All of its sides are straight. And this is one of those little extra facts, the four interior angles that add up to 360 degrees. That's not something you need to remember. It's just an additional fact. So what we're going to do is, before I look at the properties on here with you, I'm going to stop sharing my screen, because it's all well and good having the PowerPoint up all the time, but sometimes it's just easier to have a look. So can you remember the name of this shape? It's got its four sides. It is a trapezium, a trapezium. Sometimes people call them trapezoid, but this we tend to use the word trapezium. So I've got a couple of different examples here, you can see. All right, this one's slightly different in that it's got a right angle in it, and this one wouldn't have any lines of symmetry, whereas these two would have a line of symmetry down the middle, down there, and this one would have one down there as well. Now, they have one set of parallel sides. So we talked about those parallel sides, the lines that will never meet. So the top and the bottom, they would continue and they would never meet. And you can see that that one, you can see that this one and this one have one set of parallel lines. And that's true of all trapeziums. Okay. So we'll have a look at a few more facts after, but I just want to show you these ones first. Then we also have a square. Okay, should know that shape. You should know the properties. 90-degree angles. It's got two sets of parallel sides. It's got four sets of perpendicular sides. It's got four lines of symmetry. So that's our square. And I've got a smaller one there. Still a square. And it doesn't matter which way round you put it that way round. It's still a square. It's just in a different orientation. You can have it that way, have it that way. Doesn't matter. Still a square. And then we're going to move on. We have our oblong or our rectangle. All right, so it has two sets of parallel sides. It has four sets of perpendicular. It only has two lines of symmetry though, so it's a bit different to the square. All right, in that it's got no diagonal lines. All right, and it's still got those 90-degree angles. Now this is my favorite shape that I like to talk to you about in school. I'm always going, but it's not a diamond. It's not a diamond. It is a rhombus, and we will talk about the properties of our rhombus in a short while. We also have our parallelogram, which has obviously got parallel sides because it has the word parallel in its name, so parallelogram. We have got a kite, and then we have an inverted kite. Okay, so if we turn it that way round, you can see rather than it pointing upwards, it goes in. So we have a kite, it might look like this one, and then we have some inverted kites. So they're our shapes. So I've got some posters now. Okay, so these are rectangles. So it says rectangles are quadrilaterals that are also, you know what, it's lagging a bit, but I'm going to go back onto the screen now. So I'm going to share my screen and I'm going to bring it up because it's easier for you to see on the screen. So you can see my screen now. and you should be able to see the square. Okay, so all sides are equal. So there's that vocabulary from the beginning. All sides are equal length. Opposite sides are parallel. Interior angles are all equal, and they add up to 360 degrees. Now, I left this on there, although I said you didn't need to know it. It's something that you should be able to work out because you know that the squares have right angles. So what must each interior angle be? That's right, 90 degrees. So moving on, rectangle or an oblong. It has some similar properties to the square. So opposite sides are parallel and opposite sides are equal length. Every angle is a right angle. Now, squares can be classified as rectangles, but not all rectangles can be classified as squares. Can you explain why? Have a little think. So a rectangle has opposite sides of equal length and 4 90-degree angles. A square also has opposite sides of equal length and 4 90-degree angles. However, a square also has 4 equal sides, whereas a rectangle doesn't. Then we're moving on to my rhombus, not my diamond, my rhombus. So the properties are all 4 sides are equal length, but it's not a square. Diagonally opposite angles are equal. So you can see it's showing you in this diagram that those are equal angles. 2 angles are acute, so these 2, and 2 angles are obtuse, these 2. And opposite sides are parallel. So if opposite sides are parallel, what other name do you think could be given to a rhombus? That's right, a parallelogram. So that moves me swiftly on to a parallelogram. It has 2 pairs of equal parallel sides. Diagonally opposite angles are equal. 2 are acute and 2 are obtuse. So these 2 shapes do sound very, very similar. So why is a rhombus called a rhombus and not a parallelogram when it is a type of parallelogram? There's something about the rhombus that is not the same as the parallelogram. I know it's only a tiny video in the corner, but can you see? What do you think the property is that distinguishes them, that makes them apart from each other? That's right. The rhombus has got all equal sides, whereas the parallelogram hasn't. The sides are different. If it had the same sides, it would then be a rhombus, not a parallelogram. And then we've got our trapezium. Remember I showed you these at the start? Trapezium. The only property is that it has 1 pair of parallel sides. All right, so that's why you get them in different shapes. And then we're moving on to our kite. We can see it has 2 pairs of equal adjacent sides. So adjacent means next to. So this one here and this one here are equal in length. And then this one and this one are also equal in length. The angles here are the same. They are equal. They are the same as each other. So what am I? All of my sides and angles are equal. What am I? Shout it out. You can do that at home, not in school. Shout it out. Well done. I am a square. All of my sides are equal and I have two acute angles. What am I? Shout it out. Oh, well done. You've got this. I am a rhombus. I have one pair of parallel lines. What am I? Can't hear you. Well done. Trapezium. My adjacent sides are of equal length and I have one pair of equal angles. What am I? Fantastic. You've got this. You're a kite. I have four right angles, but my sides are not all equal. What am I? Shout it out. Well done. A rectangle or oblong. Right. So what I'm going to show you now is a couple of questions. So name and identify the properties of this quadrilateral. So if you had a question like this, what would you do? What name would you give it? Have a pause, see if you could answer those questions. Excellent. Did you call it a kite? Did you say that it's got two pairs of equal sides? That it's got no parallel ones? It's got no right angles? Then you'd be right. Which quadrilateral has four angles, two pairs of sides of equal length, and is not a square? What do you think? That's right, it's a rectangle. So looking at this one, what do they have in common? So what features did they share? What properties do all of those shapes share? What is different about them? So if I asked you what is different about the shapes that are there, you could say, well, some of them have got longer sides, some of them have got shorter sides, some of them have right angles, some of them don't. So, but they all have in common that they're all a four-sided shape. What about this one? How many quadrilaterals can you think of which have two pairs of equal sides? Well done. Right, so that is the end of that presentation. Now, today's work, as always all week, is on Seesaw. I'm just going to show you your worksheets today. So it's called All Groups Worksheets. Can you see it here? I'll zoom in a little bit. So it says circles. Draw the shape in the first box, then fill in the properties in the last box for each of the quadrilaterals. So you've got some paper there, and then you fill in the information. And you've got different shapes to do. Okay. Squares and pentagons. It says read the question and then write your answer into the answer box, which is why we went over some of those questions just there at the end on the PowerPoint. There's a bit of dotty paper here for you to draw, but I've also attached some at the end if you wanted to print it off. You can try and draw on this on Seesaw. You can use the pen tool to write in the answer boxes. You can use the drawing lines tool to try and draw your quadrilaterals. So they're your questions, and it says dotty papers on the next page. And then scrolling down, hexagons, you've got some questions there to answer, and there. All right. Now you only need to answer your group's questions. Hexagons, it says here, use the word bank to label each quadrilateral. How did you know which shape was which? So that should be a sentence there. It says mark any right angles on the shapes. One has been done for you. Mark any parallel lines. You can do that by, you might have noticed it in the document. You can do that. It says one shape has been done for you. So you can use these little arrows to mark it. Or you could just do it. It was in the PowerPoint with lines like that. So you would use one line to show the one set and two lines to show two. And then down here, there's a table to complete about the quadrilaterals. There's some squared paper to have a try at drawing the quadrilaterals. There's a question here, question 5. This is a square because it has got 4 equal sides. Do you agree with Rosie? And you've got a gap here where you can explain your answer. So you've got to say yes, and then a sentence to say why you agree, or no, and a sentence to say why you don't agree. And then this model down here, you can choose a quadrilateral, you can perhaps draw it at the side. Key characteristics, an example would be what it looks like. A non-example would be something that isn't right. And then a definition is just how you would describe that quadrilateral. So good luck with your maths today, and I look forward to seeing it back on Seesaw. Take care, and I'll see you real soon.